My name is Mohammed Yahya, and we are Team Derpatos, and we are going to be discussing our project that is a height-dependent gate. So what exactly is our gate? It's an automatic opening and closing system from the inside and outside based on height and proximity. So we've all been to roads or parking lots or we've seen bridges where there's a maximum height limit on the vehicles that can pass through them. The current solution that is present is a simple sign or a metal bar that puts a limit on the height of the vehicle that can pass through it. Let's be honest here, not everyone knows the exact height of their vehicle, whether it's 1.8 meters, 2 meters, or 2.2. No one really knows. So what we are proposing is this automatic gate that is height dependent and will not open except when this maximum height limit has not been reached. So, if you think about it, how can this be implemented? It can be implemented in many places, such as, for example, highways, where certain trucks cannot pass unless they reach this, if they exceed this maximum height limit. Otherwise, they will have to use their available highway, so they cannot be a burden to other cars. This can also be implemented in parking lots or commercial centers where cars can enter the parking space and leave it without having the need to worry about hitting their cars in the ceiling or the current signs that will not even be there. Now, for a quick demonstration, we will show you how everything works with my partner Mohammed.
Hi, I'm Mohammed Hidayah, and I'm going to show you how the gate actually works. First, when the car comes in front of the gate, sensor 1 is going to pick it up, and sensor 2 is going to check if it has an acceptable height. If it has an acceptable height, the gate is going to, the motor is going to pull up the gate. The gate didn't move because it does not have an acceptable height. Sensor 1 is going to pick it up. The gate is now pulled all up. When it enters, sensor 3 is going to pick it up and the motor is going to close off the gate. Now the driver is going to press the button to get out of the garage. The gate gets pulled up. When the car is out, sensor 1 is going to pick it up again, the motor will close the gate.
I'm Ahmed Al-Qasid. I'll be talking about the hardware connections for the project. So first of all, we'll have the Altera board here, but it's not available right now, so we're going to have the Altera board here. We're having this voltage source for the 3 proximity sensors. It's connected to the breadboard here, and these are the input and output voltages for all 3 sensors. We also have the red LED light, which determines if the gate is in the process of opening or closing, which is also connected to the ground here. And this is the voltage source from the Altera board. It's the 5 volt voltage source. It's connected here. That's from the Altera board. That is ground, and it's connected to the motor. That's the motor driver right here. It has these 2 connections from the voltage source, and these 2 connections which are the control inputs, which control how the motor moves. Either it opens the gate or it closes it. And these are the wires connected to the motor, so it can, so it actually do close or open. What else? Oh, the proximity sensors. All 3 have the same concept. These are for the voltages, the input and the ground, and this is for controlling it and what to do with it through its pin and the Altera board. That's it for all 3 proximity sensors. This one, and that one, and that's basically it. And the green LED light is also it's there, so it determines when the gate is open and the driver is ready to get inside. That's basically it.
Thank you. So
name is Aya. I'm going to be talking about the sensor module. The sensor module takes in, as an input, takes 5 inputs or returns 2 outputs. It takes the 3 sensors as input, a clock, which is generated by the board, a button, two outputs, open and close, which are given as inputs to the motor module. First of all, we check if we're counting. If we're not already counting and the sensor detects something, then we start counting. Then we check if we are already counting. Then we increment the counter until it reaches 150 million. Once it reaches 150 million, which is equivalent to 3 seconds, the counter is incremented. The counter is initialized to 0 again. The counting is the counting variable goes to 0 again. If sensor 1 does not detect anything during the counting process, then the counter is initialized to 0 again, or counting is initialized to 0. It will mean that there was a car passing by the gate, however, it did not want to go through the gate because it did not stay for the 3 seconds. But if we've reached the counter and we already initialized it to the counter to 0 and counting to 0, we check the second sensor, which is sensor number 2, and which checks if the car is at the correct height. If the car is of a correct height, if it is and the sensor does not detect anything, then we put the open variable, or initialize the open variable to 1, and we initialize another variable called opening forward to 1, which opens the gate forward so the car can pass. The open variable is given to the motor as an input, but the opening forward is used in the loop, and it's checked. If opening forward is initialized to 1, or if it is equal to 1, and sensor 3 detects something, sensor 3 is behind the gate, so this will mean that the car already passed the gate, and the gate will close. We will initialize close to 1, which is also given to the motor module. There is also a button on the Altera board, which if clicked, the gate is going to open. We're going to set opening backward to 1, and we're going to set initialize open to 1, which is given to the motor in order to open the gate so the car can go back. Once the car goes backward and the sensor number 1 detects the car, it will set initialize close to 1, so the gate is going to be closed after the car. Next up, Hassan is going to talk about the remaining modules, which are the motor modules and the main module.
Hello, I'm Hassan Al-Karim. I'm going to be talking about the motor module and the main module. The motor module has 3 inputs and 4 outputs. The 3 inputs are the clock, which is 50 MHz, the open and close signals, which come from the sensors module. The outputs are bit 0 and 1, which go through the motor shield that controls the motor, and the green LED signal and the red LED signal. We also have a register called state. We have 4 states for the gate: closed, open, opening, and closed, so we need 2 bits. Initially, the state is 0, which is closed. In the always block, first we check if the state is 2, which is opening. We're going to count. First we check if the count hits the maximum, the maximum, which is 50 million. We're gonna set the state to 2, which is opened, and we're gonna stop the motor. If it's not, if it didn't hit 50 million, we're gonna just increment the counter and keep the motor running. If the state is closing, we're gonna do basically the same thing. We're gonna check on the counter. If it hit 50 million, we're gonna stop the counter and set the state to 0, which is closed. Else we're gonna increment the counter. The last check, we're gonna check if open is equal to 1, which is the signal that comes from the sensor module, and the state is not 2, which is closed. So if the sensor wants us to open the gate, but the gate is opened, we're not gonna open it. We're gonna do the same thing for closing. If the sensors want us to close the gate, and the gate is already closed, we're not gonna do anything. For the main module, we have all the inputs and outputs. We have the clock, the sensor 1, 2, and 3, and the open button, which opens the gate from the inside. We have the outputs, which are the motor bits that control the motor shield.